Hello and welcome to our first single-pair Ethernet System Alliance Roundtable discussion. My name is Alina Grove and I'm very pleased to welcome three exciting guests here today. So with me is Simon Seereiner from Weidmüller, Marine Boutioubon from Fischer Connectors and Thomas Keller from Rosenberger. And today we want to figure out what's behind the big statement, single-pair Ethernet is unstoppable. So, where are we today? Fact is that we are on track for 50 million SPE nodes in 2030, alone in factory automation. So that's a huge number. And this is really no fantasy, because the forecasting model of the SPE System Alliance indicates this. And of course, they're going to push this development further. So that's the starting point for today. And now let's get started and jump directly into the discussion. So we heard that SPE is unstoppable, but why is that? Can you explain that to me?
Well, Alina, we all know that today our world is undergoing a very deep paradigm shift with the advent of digitalization. And while the currency of digitalization is data, which means that the way this data is transmitted is really moving at the center of the focus. A good example of that is what we can observe in Industry 4.0, right? Where a whole collection of devices must interact together efficiently to ensure proper plant operation. And when I mention devices, I mean sensors and actuators in the field, but also the cloud. And this means that new communication enablers are needed that must pave the way for a seamless communication without barriers from the sensors to the cloud.
Okay, and what exactly is the role of SPE in that seamless communication without barriers?
Look, Alina, where are the barriers in the data communication based on IP protocols? The barriers are the different communication technologies. And all the communication, wired or wireless, are working on IP-based networks. So modern systems work with Ethernet. But on the level of the field devices, where you have your sensors and actors, the communication is mainly based on different bus protocols. And to transfer your data from a bus system into Ethernet, you have barriers. But SPE provides a seamless communication without barriers because it has the same communication architecture as we already use today almost everywhere, Ethernet, and it's defined in the IEEE 802.3. So SPE is a physical layer that can be seamlessly integrated in any Ethernet application. And that's why SPE is the enabler for IoT, IIoT, and Industry 4.0. If you want to implement SPE, you can maintain almost everything. You only have to change your PHY and kick out your gateway, and that's it.
Well, this is very interesting. And now, are there also any technological benefits of SPE compared to standard Ethernet?
Yes, Alina, indeed they are. Well, as we just heard from Thomas, single-pair Ethernet is standard Ethernet. But the big thing is that we're using just 2 wires instead of 8. And that makes the whole thing very, very small and allows us to realize miniaturized IoT devices. It also makes the implementation of that technology very simple because from the connector point of view, you just have to harness 2 wires on a field attachable connector. And on the other side, power and data can be seamlessly transmitted over one cable. So we can power up intelligent field devices or intelligent network sensors with up to 50 watts and have the data being transported over the 2-wire cable at the same time. And of course, as we are using standard Ethernet, it can easily be integrated into existing field bus infrastructure. So for example, avoiding the necessary gateways by seamlessly communicating from the field devices directly to the PLC. And last but not least, Ethernet is restricted to maximum 100 meter for copper Ethernet. Now, single-pair Ethernet provides the possibility of realizing a 10 megabit standard with a maximum length of up to 1 kilometer, and that makes it quite interesting for many different applications in the factory automation field, but also in the building automation field, in smart cities, in long-range applications. So the possibilities are really infinite for the usage of single-pair Ethernet.
Well, this sounds already very great. And are there also any cost benefits as well?
Yes, well, We achieve the possibility in realizing, for example, the connectivity in the same range as the RJ45 after ramp up. And the another big benefit is that you have much smaller devices where you have higher port density, so you can easily integrate more ports on a device. You also save a lot of cost by avoiding all of the necessary gateways that we have today in the field bus architecture. And on the other side, your employees and the future generation of students and engineers coming out of the university, they know Ethernet by heart today. So you don't have to train them on, let's say, older field bus protocols. Just as an example, Weidmüller and Rosenberger made an internal calculation with their specialists for machine building, asking the question how single-pair Ethernet could save cost on the next generation of machines. And at Weidmüller, for example, we calculated a possible cost saving of something like 25% by building up a seamless network and avoiding all of the gateways, the different complex field bus systems, and having just one network for the entire machine. So, you see, there are a lot of benefits for single-pair Ethernet.
So this sounds really great. And I also heard that you developed a model for SPE. So I'm curious, how did you do this?
A few years ago, the IEEE assumed the market potential of SPE. It was a 250 million node story. In that story, they separated the 250 million nodes in different market segments and predicted a forecast model for the factory automation of 50 million nodes. But we from the System Alliance developed our own model to evaluate the SPE nodes for that market. For that model, we took the historical data from the market development of field bus systems, industrial Ethernet, and wireless technology, which you can get from Profibus, Profinet International, and the company HMS. So we took that data and had a look into the market development over time and the effect of an implementation of a new technology to the existing technology during that time period. This data shows a huge growth rate of the industrial Ethernet, especially compared to the field bus technology. For example, in the factory automation, the industrial Ethernet reached in 2014 a market share of almost 30%. Last year, the industrial Ethernet reached in the factory automation a market share of 65%. That's a great success story. And also a great success story for industrial Ethernet is here Profinet. And Profinet announced nearly 50 million nodes in 2021. And based on that complex data, we developed our calculation model.
So concretely, how did we do it? Well, luckily here at the Single Pair Ethernet System Alliance, we happen to have a shiny collection of experts that have been in the field of industry automation for quite a while. And so to build our model, we just started to collect and document their expertise and experience. And then we integrated it in a model for the adoption of industrial networks based on the data that Thomas just mentioned. And then all that was left to do really was to estimate the proportion of cannibalization and absorption of other technologies, which led us to this 15 million nodes by 2030.
Well, thanks for the explanation, Marine and Thomas. And now to wrap it up, Simon, could you summarize in a few words?
Well, Alina, I think we were able to show you that single-pair Ethernet is really unstoppable. It's not a question if it comes up, it's just a matter when it will hit the market. As we heard from Marine, data is the new oil, and that needs to be transported easy and efficiently. And we believe that single-pair Ethernet provides a lot of benefit compared to standard Ethernet and has the potential to also bring a lot of benefit to existing field bus infrastructure. We, from the Single-Pair Ethernet System Alliance, have calculated a sophisticated model showing that 50 million nodes by 2030 are achievable just because of the implementation of that technology. So if that is interesting for you and you want to be part of that fast-growing community of Single-Pair Ethernet specialists, why not considering joining us here at the Single-Pair Ethernet System Alliance? We are now 42 members organized in various different working groups, and we're always looking for new technology enthusiasts to implement that technology in the market.
Great last words, Simon. So I think you left nothing more to say. So thanks to you all for the great discussion, and I'm already looking forward to the next session.
Thank you.
Thank you, Alina.
Thank you.